Okay, so I got a little bit cut off at the end of that last one, but we were going over this multiplying fractions, showing that we could have multiplied across the top and across the bottom and then simplified, or we could do the cross canceling here. 2 goes into both of these and we get right down to that simplest form. Dividing fractions, we keep the first fraction, we change that division to a multiplication, and then we flip the second fraction. And then it's just a plain old multiplication problem. Now, rather than me trying to figure out 4 times 28, I just chose to use the method where I cancel out. 7 and 28 both have a common factor of 7, so I can take 7 out of both of those. So 7 becomes a 1 and 28 becomes a 4, and I get 16 over 5. So again, any of these that you're not sure about, put a little note next to them and ask about them in class or in office hours. Okay, this should all be review. If it's not to you, that's fine. But that's why I'm not spending tons of time on each topic. So if you aren't remembering this, just please make sure that you connect with me. Okay, so next, roots. We talked about this a little bit when we talked about rational and irrational numbers, okay? So a square root, for example, okay, is asking what number multiplied by itself equals the number in the, we call this a radical sign. Okay, the square root sign is a radical sign. Let me just neaten this part up a little bit. So the square root is saying what number multiplied by itself equals this number here. So in other words, we want to know what number times itself equals 100. Well, hopefully it kind of jumps out at you. That's going to be 10. Now, I left this little space here because if we have a larger root, this is called a cube root. It has this little 3 right here in the crook of the radical sign. That really is saying what number multiplied by itself 3 times equals the number here. So I want to know what number times itself 3 times equals 8. So it's not something times 3 equals 8. Oops. It's a number multiplied by itself 3 times equals 8. Okay, so in this case, this is actually going to be 2, because 2 times 2 is 4 times 2 is 8. So my answer here is 2. Now, you want to get familiar with your calculator and how to do these on your calculator. I have this little calculator up on the screen. Here's my square root sign. It doesn't usually have the 2 in here. I don't know why this calculator does. Usually it's just the square root sign. But your calculator probably either then has a cube root sign where you can do the cube root and then whatever number you want, or it may have something where it has like an X here and a Y here, so you would put in the 3 first, then this button, and then the 8. You might have to kind of play around with it, and I can help you also. I can look at those and see how your specific calculator works. Okay, and then exponents are kind of the opposite of roots, right? So this is saying, here's my exponential expression. This is what I call the base, and this is what we call the exponent or the power. And so we have the base, the number of times of the exponent, right? So it multiplies by itself. So in this case, it's going to be 3 times 3 times 3 times 3. Now this is not 12, it's not 3 times 4. 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. Okay. If we have this one, this is saying -2 to the 3rd power. It's saying -2 multiplied by itself 3 times. So think about the negatives here. -2 times -2 is going to give me a +4, and then 4 times -2 is going to be -8. Oops, 4 times -2 is going to be -8. Okay, let's skip number 3 for a second because I want to give you a better example in a minute. Number 4 is a special case, okay? Something you need to remember is that anything raised to the 0 power equals 1. So this is going to equal 1. Right now, it's just a rule I want you to remember. When we get a little farther on in the semester, we'll talk about exponents more. and I can kind of show you why. So let's look at another example here. What if I have -2 squared? And we talked about this a little bit in at least one of the classes. So -2 squared, this whole thing is being squared. That means -2 is multiplied by itself. -2 times -2 is +4. Now what if I have -2 squared with no parentheses? Well, the thing about the exponent is it only goes with whatever it's right next to. So here, this exponent went with these parentheses, so everything in parentheses was being squared. Here, the exponent only goes with the 2, so I'm just squaring 2, and then this means at the end, just stick a negative in front of it, make it negative. So this is going to be the negative of 2 times 2. 2 times 2 is 4, the negative of that is -4. So if you want to square a negative number and you want that negative number to be multiplied by itself, then you have to make sure it's in parentheses in your calculator. Okay, so absolute value. Okay, absolute value is always positive. The reason it's always positive is because it really tells us the distance from 0 that a number is. So let's pretend we were standing on a gigantic number line, and you were standing at the number -3. Okay, so here's our number line. You're standing here at -3. How far are you from 0? Well, you're 1, 2, 3 hops from 0. What if you're standing on +3? You're still 1, 2, 3 hops from 0. So distance does not have a positive or negative to it. We might say to the left or to the right or up or down, but the distance itself is never going to be negative. I can't say go walk -3 feet down the hall, right? So whether you're at +3 or -3, the distance is always going to be 3. So these upright lines are the absolute value. That's really what it means. You can also just think that your answer, your number in the absolute values, is always going to become positive. Okay, so that 0 is not a exponent there. It's just the 0 from the number line. So the absolute value of -25 is just going to be +25. Now when we get to here, we're not making each individual thing positive in here. We're doing the work first, and then when there's just one number in the absolute value, that's when we make it positive. So -12 minus 10 is -22. This is like saying -12 plus -10, if that helps you. And then the absolute value of -22 is +22. Okay, so let's look at order of operations. And again, one of the classes was able to look at this a little bit. I don't think the other one was. So order of operations, we talked about that this is just a rule that we use so that everybody who does a certain mathematical expression, simplifies an expression, does it in the same order, just so we don't all get different answers, okay? So this is just a little silly way we remember to remember what our order is. You might have learned PEMDAS, you might have learned Please Excuse My Dear Aunt Sally, you might have learned neither of those, and that's fine. But what do these stand for? So P stands for parentheses, or another grouping symbol. So absolute value is actually in there. Okay, anything that can kind of group things together and have operations in it. E stands for exponents or roots. Okay, roots are actually an exponent of a fraction. You don't need to know that this semester, but that's why they're at the same place. Now this is where it gets a little messy, okay? So if you've learned one of these little tricks, either it's my dear and then Aunt Sally, or you've learned PEMDAS in this order. But multiplication is not always before division. So these two tell us we're going to do multiplication and division, but we go from left to right in the problem. So if we're walking from left to right, if we're a little bug walking across the problem, whichever we get to first, multiplication or division, we do that first. And then we go back and do the rest of the multiplication and division, again from left to right. And then we do the same thing with adding and subtracting. So we add and subtract from left to right. So again, We don't always do addition first. So if we had this little PEMDAS, right, it would be just as correct to have this little trick instead, to say PEDMASA, right? Because multiplication is not always before division. They're just at the same level done left to right, and same with addition and subtraction. All right, so I'm going to pause this for just a second so I can plug my computer in because I don't want it to die. So if there's a little hiccup in the video, that's why. And then we'll come back and we'll talk about this number 1 here. Okay, so let's take a look at this first example for order of operations. We're going to simplify this number 1 right here. So we are going to go through step by step and follow that order of operations and do one step at a time, and I'm going to very strongly suggest that you rewrite the whole problem for every step. Okay, otherwise it's very easy to kind of lose where you are and not simplify things correctly. So we're going to look through. So we first know that we need to look for parentheses. Now there is a set of parentheses here, but there's nothing to do in the parentheses. The parentheses are there because there's a negative number raised to a power. So we don't actually have anything to do in there. It's not like it says 2 plus 7 or something like that in the parentheses. So really we're just moving ahead to exponents, which is right here. So I'm going to rewrite everything that goes up to that exponent. And we know from above that anything raised to the 0 power is going to be 1. Okay. I also want to point out that here we have a x for multiplication. That's probably one of the last times you'll see that in this class because we're going to be moving into using variables in chapter 2. So we don't want to use x for multiplication because that would be confusing. We can use either the dot for multiplication, like this, or we could use parentheses to show multiplication. So let's get used to one of those. Okay, so now we've done exponents. There are no more exponents or roots. So now we're in this multiplication and division part. So again, pretend you're a little bug and you're walking along from left to right, and you first come to subtraction, then addition, then subtraction, then division, then multiplication, then addition. So if I'm looking at just multiplication and division first, I came to division before multiplication, going from left to right. So I'm going to rewrite everything else that I have. We have negative 16 divided by 4 is going to be negative 4. So this part right here is what we did first. And then I keep writing times 2 plus 1. Okay, so then I go through again and I'm going to do multiplication next. So I do 14 minus 5 plus 3. And I'm going to be doing these two numbers right here. So negative 4 times 2 is negative 8, and then I just bring down the plus 1. Now for both of these, you might be saying, well, if I have negative 4 times 2, how do I know, is that minus 4 times 2? Is it a subtraction or is it a negative? It kind of doesn't matter, because if you think about it, the way we add the opposite, subtracting 4 or adding negative 4 is the same thing, okay? So I can either think of it as negative 4 times 2, which would give me negative 8, or I could think of it as 4 times 2, which is 8, and then subtracting that 8, right? So either way, it really gives us the same thing. That's something sometimes it's a little hard to wrap your head around. Okay, so now we've done all the multiplication and division, and now I can do subtraction and addition from left to right. So again, I'm a little bug, I'm walking along here, I get to this 14 minus 5 first. So I subtract that, I rewrite everything else. 9 plus 3 is going to be 12. 12 minus 8 plus 1. 12 minus 8 is 4. Rewrite everything else. 4 plus 1 is 5. Okay, so I'm going to, I'm going to ask you to pause the video for a minute. Try number 2, 3, and 4, and then when we come back, we'll go over them. Okay, so here's number 2. Here we did have parentheses right here. We add that first, and then we do our exponents and roots. Again, we work from left to right when we have more than one thing in a category. So square root of 36 is 6, the square root of 25, then the next step is 5. We square 1.7, 1.7 times 1.7